Hello everyone and welcome. So in this video I'm going to be breaking down how I did this procedural boat in Houdini. So this should be a fun exercise and hopefully you will get away with a few tips. So let's start at the top. I'm starting this just with a line along the z-axis, doing a resample with 40 points. Basically you define the resolution of your base, the base of the boat. Then deforming the shape just with a channel ramp, nothing too complicated, just along the position Y, and you define the shape you want. And this will be our initial shape, and I'm computing the normals along the x-axis. So the out, usually this is called out, and I'm just setting it to n. Then on this part I am doing the other parts of the model, and for that I'm just blasting the first and the last point of this curve, this initial curve, as you can see in here. Then resampling it and sweeping by setting it to ribbon and columns, just one in this case, you can set more if you want, playing with the width and doing a scale ramp so we get this fall off or this curvature, as you can see. For some reason I'm doing again an orient along curve in here to set it along the y-axis, the normals, and then displacing along the normals and with a channel ramp and creating this sort of effect, as you can see, to create the shape of the boat. So these are the initial lines that will define the shape of the boat. I'm sorting the primitives by X and skinning, in this case setting it to columns. If I didn't sort, they will get all messed up, so we need to sort them by X. Then doing the skinning, and we get this sort of shape that now we can now create the back part of the boat, as you can see, just by adding the from the primitive 0, the point 0 to the point 82, if you can see in here. So we're adding that back part, then resampling and setting it to interpolating curves to create the boat shape, as you can see. What am I doing in here? I'm sorting by the z-axis, so I can easily select one of the primitives in here. This will be for the UVs, so I'm promoting that to points after it. And first of all, before doing the UVs, I'm skinning the shape, and if we reverse and fuse and apply the normal, we will get the boat shape, as you can see, as simple as that. Then I'm doing the UVs, so I have that group where I will cut the shape. So first of all, before applying that, I'm grouping by the min edge angle to get the hard edges. Then promoting that range group to edges and doing the UV flatten, which will look something like this. But then I want this part to be flat because I'm gonna do an operation after it. So I'm creating a connectivity on the UVs and grouping that specific part, which is class 1. It will always be based on the area of that UV shell. So in this case it will be the middle one, so 1. And promoting that to vertices, so I can do a new UV flatten and preserve the seams, and a rectify group I feed that specific group, and then we get that group rectified. So this is one way to manipulate UVs. So we have that basic shape. What am I doing in here? I'm creating a planks attribute, which will be based on this resample that we did in here. So resample 6, which has 10 segments, as you can see. So this one in here. And so I'm creating that planks attribute so I can divide it into planks, as you can see. Let me get rid of the UVs and the visualization of the curve. And now we can just vertex split based on that planks attribute. And poly extrude it, just inset it a little bit and remove the side prims. So I'm just insetting a little bit. Then I can poly extrude to create the stripes, and you get this sort of result, as you can see. Hopefully you can see it with the recording. And this will be the base of the boat. Then we can create a line and do a small transform to place it where we want. In this case, I'm going to create in here a platform Then I'm ray projecting this along the X. So I'm just ray projecting it to the boat, doing a mirror, and then doing the skin to create this particular platform, and then we will close it in a bit. So what we will look next, let's see, in here I'm loading these curves from the initial setup, doing a group by range because I want to create the seat in here. So doing a group by range, just selecting 10 out of all the points and affect disconnected geometry, so by connectivity, so we can select on both sides, and blasting those prims, blasting everything else, I mean. Then I'm loading the base model of the boat, so just the skin shape, and blasting that particular class that we rectified, as you can see. Then we can copy the UVs to the curves with a UV sample, so it will look something. We should have the UVs in here. For some reason, I'm not seeing them. So we have the UVs in here, and we should... Oh, I'm not saving as UV. I am saving at underscore UV, so it doesn't output UVs in this case. So this will copy the UVs from the shape to the curves, and then I can just offset them along that particular shape, as you can see, by setting first the UV attribute or the UV variable and offsetting along the Y by a defined amount, and I can move them up and down, as you can see. And in this case, I want to move them in opposite directions, so I can just set a sign on the prim num and make it between -1 and 1. Then the position is just a UV sample with that fitting those UVs. So that's a nice trick to know. Then I'm just skinning, subdividing, and doing the normals, and extruding it a bit, as you can see. And this will be the seat. So we have the base shape, this seat, and this part here in here. Let's look at this part now. So I believe in this part I'm closing this gap in here. So I'm converting this initial shape we have in here, this platform as I call it, and I'm converting it to line, sorting by the Z, I believe, yeah, and then blasting the primitive 0. Since sorting it, I will have the primitive 0 always here. So this is still procedural, and we're blasting that primitive, resampling, and ray projecting to the boat. As you can see, I have the boat shape in here. And if we merge it, we will have this, and we can just skin and fuse, and we will have the closed platform. And if we look at the boat and this part in here, we should have the basis of our boat. So now we will have a look at creating this cabin in here. It's simple, but still has some things to it, some caveats. So I'm starting with a box and match sizing it to this platform we have in here. And then I'm going to create, in this case, I'm going to need to do some booleans to cut out the holes for the windows and doors. So then I will copy the windows and doors. So I need to create some points from this shape. So for that I'm going to shrink wrap it and do like a 2D shrink wrap to create it's like extracting the silhouette along the Y. So I'm just offsetting a little bit and set the plane normal to be along Y, using just in case and converting to line. Now we will look in a bit on what I'm doing in here, but for now I'm just going to create the normals by normalizing P and setting the normal.y to 0, so we have these flat normals pointing out. Then I can do a simple dot product between the normals and the negative z-axis, so I can select only the front points because I don't want doors or windows at the back, so I can blast those points. And I'm also going to do a manual selection in this case of the door point, which will be here on the right. Then I'm just doing in here a transform just to offset a bit the windows and doors to be at the top. And in here I need to make sure I have correct normals for the instancing. So I'm just UV sampling the normals from the box, and it will give us these straight out normals pointing out. Then I'm doing a basic transform to the door which will be based on the height of my door that I have in here. So based on what we're going to do next, in this case setting the P scale and setting the scale of the door. As you can see, I'm just selecting that point from that group, and I'm affecting the Y scale of just that point and setting the others to 1. This is scale, not P scale. The P scale I'm just multiplying by or setting 0.1, and we will have this. But we need to have uniform distribution, because right now if I have this shape in here and I do a simple resample, and let's say I'm gonna have this amount of doors and windows, and I remove this and I copy these 2 points. As you can see, we can't make them. First of all, if we remove the corner points, which there are ways to do it, we won't have the perfect alignment. As you can see, they will have more gaps, more gap space at the edges and less in the middle. So we need somehow to do a uniform distribution of these windows and doors. And I'm gonna attempt to explain you what this one is doing in here. So if I show you, as you can see, we have the same amount of gaps and uniform distribution. There might be other ways to do this, but I did it with Vex. Basically, we set the amount of windows and doors we want. We can't have much more. We can only fit 3 for this amount of for this size of the windows, and we also need the window width. In this case, I'm setting it by the width, the size x of the geometry being copied multiplied by the P scale. So that's just that. That's the window width. Then I'm extracting from this box, as you can see, we have several prims, and I'm extracting the first and the second point using prim points, and extracting the first and the second point's position, as you can see in here. Then I'm calculating the direction, so from left to right, or in all the directions, in all the faces, I mean. From there, I also, since I did the convert line, this computes the rest length, so I can just use the length. The length can be just this rest length. Then the total windows will be the number of windows times the total window size. I mean, it will be the number of windows times the window width, so window width times 3. Then we need to calculate the equal gap size. And for that, we can just, from the length of the initial curve that we have, that's the wall, we subtract from the length the total amount of windows and divide that by 4 gaps, so the number of windows plus 1. Then we just iterate over each amount of points, and we do the calculation, basically starting with the gap multiplied by the current iteration plus 1, so it creates, instead of starting from 0, it will create the first gap. Then we add the window width and multiply it by so we need to accumulate the offset of the window width and the gap width. So we add the window width and multiply it by the iteration, which will be 0 at the start, so we need to offset it by half of it, so the point is in the center of the window. And that's what we're doing in here with this one. Then we just create the position for the point, which will be from the point 0. So from the point 0, which will be at the left, and we add the direction, and we multiply it by this offset we calculated in here. Add the point and remove any prims. So this is just creating the necessary points. It's a bit overkill, I know, but in the end it works, and I'm happy with it. Then I'm just doing a boolean, and we get this equal distribution. Might come in handy in one of your future projects. And if you have another solution, please let me know. I would love to hear your thoughts. So after the boolean, we're just blasting in here. I'm going to do some blanks here at the bottom, some divisions. So I'm just blasting from this boolean the b inside a, which are the b primitives. Getting rid of this bottom by doing this split prim binormal and selecting y, then clipping and getting rid of the top prims, and I'm going to divide this. and this division we will just be the bricked polygons, and we're going to take the x-axis and divide it by the number of divisions we want. So we can just set how many we want, and we copy the same value to the size z, as you can see, and we will have the same amount of divisions. Then just doing a poly extrude, as always, doing an inset and removing the side prims, doing an extrusion. And what am I doing in here? So, in this case I'm creating in here a rail, some sort of rail. So I'm just, in this case, creating a shrink wrap, converting it to line, and we will have still this shape that we want to get rid of. So for that, I'm just selecting the door point in here. So blasting the door point, doing a ray projection on that curve, and attribute copy the hit prim, and then we can get rid of that primitive. Doing a fuse, polypath, and sweep with a simple shape, as you can see in here. And it will look something like this. If we add everything up, we have the base of our cabin. Let's see, from this boolean, I'm also group expanding the B inside A, or shrinking the selection and getting the windows so I can color them black. And in here I'm just creating the doors, so in this case blasting everything but the B inside A, calculating the area and the max area, and just comparing if the area is equal to the max area, so I get the door. In here I'm calculating the width and the height of these elements, and I have a door from a previous project that I'm from that computed width and height. I'm feeding in here the size, so I get the perfect size. Then just offsetting it to the original position of the door, and making sure I offset it a bit on the z-axis with a match size. Then we will have the cabin. That's as simple as that. And I'm also loading in here the boat and also the shell, so I can cover up in here this inside. So this is just creating a sweep from the outline curves, and we get something like this. So let's finish this by having a look at how to create the zanging wires. So starting with the curves again, the initial curves, deleting any attributes and fusing them, and creating a polypath to have a unique prim, as you can see. Then I'm sweeping to create these columns, setting it to ribbon and columns. Then blasting the inside one, poly cutting at the center point, and doing a resample for the amount of, in this case, the amount of hanging wires we want. So just set the length we want. Grabbing the ends just to make sure we don't affect those. And in this case, I'm just offsetting just randomizing the points that are not the ends. So I want to keep those. And this is simple enough, doing prim UV and making sure that we feed a random position to the U of those new UVs we will compute. Then converting it to line, and we get a different primitive for each section, resampling it, and just offsetting them down by computing the curve view, doing a mirror-like effect. We have done this plenty of times, then channel ramp that, and creating a fall-off. Then we're just offsetting them along the Y by that U amount, that curve view, and also doing a small random so we can have more or less offset. Doing a resample, polypath, and sweep. So we get something like this. And this is the final result of that part. And now in here we're just gonna create these wires. That's simple enough. We're going to start with the lines again, with the curves, reversing them and carving by extracting the points. So I just want to place the wires at a specific location. So I'm going to extract the back and the front points, then making sure we enumerate just creating an index for each point. We do this, we do a blast of an initial line, and we point generate 4 points, which is the amount we have in here, and we do again an enumerate, and we will get this. So 4 points at the top and 4 points at the bottom, and we just add by attributes index. Resample, computing the normals just by normalizing the position. So we'll get something like this. Then we can just offset the position along the normals by this hill ramp, as you can see, to create this gravity effect. Sweep it, and in here I'm just sweeping the initial curve that we did in here, as you can see, and we get this sort of result. So yeah, guys, hopefully you learned something from this. This was just an experiment to try a bit procedural modeling. And let me know in the comments if you grabbed something from this. As always, you can get the files on my Patreon, alongside with hours of exclusive tutorials, all the project files from my videos, and I also have some exclusive courses on the Patreon shop, so check those out. Thank you for watching, and I'll see you around.